statement using the epsilon delta definition of limit. And there's a more or less a format that we're going to use that I think would be better if everybody's stuck with. We can do some scratch work, which is optional work that I'm just going to summarize some of these things here. The function f of x is 3x minus 1. A is the number that x is approaching, that's -2. L is the limit, -7. And then I'll just go right to the proof. So for the proof, I'm going to start off with let epsilon be greater than 0. Some textbooks say given epsilon greater than 0. Okay, ours uses let epsilon be greater than 0. And then I'm going to choose delta. Now, this is the equation of a line, and we talked about the little shortcut way of finding out what delta is going to be. Who can tell me what delta should be?
Coefficient of x, so 3.
So what am I actually going to write down for delta then? Delta
Epsilon over 3.
Yes. And then I write if 0 is less than absolute value of x minus a, and a in this case is -2, and if that's less than delta, then, so what I'm doing here is I'm assuming that the absolute value of x minus a is less than delta and greater than 0, and I'm assuming that delta is epsilon over 3. Those are the things I'm working with. I have those two things that I'm working with. And what I'm going to do is I'm going to show that the absolute value of f of x minus L is less than epsilon. I want to walk through steps to show it's less than epsilon. What else is there to say? Okay, what does this absolute value of x minus -2 less than delta mean? It means the distance, if I assume the distance between x and -2 is less than delta, and x is not equal to -2, it's greater than 0. So I want to make x close to -2. How close? Within a delta of -2, where delta is a third of my epsilon. Now, what I want to show is we want to show that absolute value of x minus L is less than epsilon. We want to show that. So then what I do is I replace f of x by 3x minus 1. I replace L by -7. And so then I get 3x. Well, sort of, okay, I was going to just be sort of, I think I'm doing it wrong. No, okay, all of a sudden I did it. Not the whole thing, just like something, okay. Take my time, don't rush. I mean, this is now, see what happens, it's just elementary algebra here. 3x plus 6, okay, then I simplify it. I put what f of x is 3x minus 1. I put L is -7, and it simplifies to 3x plus 6. And then I factor out 3, and that leaves times x plus 2. And then, okay, here's the thing, is that this is all under absolute value. We want the absolute value there. But I'm going to pop out the 3. If that is negative, if it had been a -3, when it pops out, it becomes positive. So it's really, I'm taking a product under absolute value, and I take out the absolute value of 3 and the absolute value of x plus 2. But the absolute value of 3 is just 3. This time I showed that step. Usually I don't show that, and I can see why, because it's taking up this space. Okay, and then look, from above here, just as it says, absolute value of x, well, it's not so clear, but absolute value of x minus -2. Let's do a little track down here. Absolute value of x minus -2 means absolute value of x plus 2 is less than delta. Then I just multiply both sides by 3, and I get absolute value or 3 times absolute value of x plus 2 is less than 3 delta. So here I write less than 3 delta. Okay, getting somewhere. But I got to choose what delta is. I don't choose what epsilon, but I choose delta. And I'm going to choose that delta is epsilon over 3, exactly for the reason that the 3's cancel out here. That's why I'm doing that. And that gives epsilon. And that is exactly what I wanted to prove. There is a format we want to stick to. We want to stick to this format because worldwide people recognize this format. And someone might, from some other place, might have a different way to do it, but they will at least, they're a mathematician, they will know this format, even if they prefer a different one. So we're going to stick with this format like that. Are there any questions about that?
Since a is a -2, wouldn't we have to like factor out a -3 to have x minus 2, not x plus 2?
Let me just do one line here. See where it says x minus -2? That's, see, it's x minus -2 less than delta. All I'm doing is, a minus and a minus make a positive. It's just, it's the same as x plus 2.
Okay.
If you factor out -3, then that would give -x minus 2. So,
Oh, okay.
yeah. It's, the thing is this, this, maybe I should have, I did, I have my little side here, but it simplifies to, it's good to show work, right? Although it does fill up the page, but x minus -2 absolute value is the same thing as x plus 2 absolute value. Well, let's check out this problem. Then we'll stop the video. But unless, do you want me to, maybe I can just zoom out here so you can look at that at the same time. Okay. This is, it's a total different thing here, where we're going to evaluate this limit using the limit laws. And so it's a totally different thing. That was about proving a limit exists using the epsilon delta definition of limit. Here we're going to evaluate the limit using the limit laws. Maybe I should say that in the, but if I put in t equals 9, I get, we should get, we'll see that we'll get a 0/0 form. 9 minus 9 square root of 9 minus 3, and that's a 0/0, and that's an indeterminate form. Meaning that just by looking at it, I'm not, that's what it's called. But I'll interpret that to mean that just by looking at it, it's not clear what's going to happen. We don't know what the limit will be. It might not even exist, but okay. There's a thing that we do when we see a problem with this limit with a radical. And in fact, it's not just these limit problems. There's a whole topic in the beginning algebra class of rationalizing the denominator, and you use the same method. Okay, what I do though is I'm going to multiply what's called the conjugate of the radical. It's radical t minus 3. I multiply on the denominator by radical t plus 3. And I do that for both the numerator and the denominator. And then I go from there. Let's see what happens. Well, the denominator is going to simplify to a difference of squares. We have radical t minus 3 times radical t plus 3. So then I get radical t squared minus 3 squared. This is like a minus b times a plus b equals a squared minus b squared. That's the idea here. Okay, that's what I'm using. All right, that's the whole idea. Okay, then the numerator I am not going to multiply through. You'll see that I don't want to do that. It's already factored out. I want to leave it like that. And especially the next step will show that we don't want to multiply the numerator because the denominator simplifies to t minus 9. There's a mistake here, a little typo. It's I don't know what you call it. Rad t minus 3 times rad t plus 3 is rad t squared minus 3 squared. It should be minus 3 squared. So it's we have these squares there. Okay, so that becomes t minus 9, and the numerator t minus 9 is there. Those will cancel. And those cancel out. And so I have the limit of what's left, radical t plus 3. And if I plug in 9, that does not result in any division by 0. The problem was plugging in 9 gave 0 divide by 0. 0 in the numerator, fine. But it was division by 0, 0 in the denominator that was the problem. Alrighty, so sort of a classic problem involving a radical. Does anybody have a question about that?